Imagine the universe in all its breathtaking complexity and boundless expanse, as a massive puzzle, an intricate cosmic jigsaw with pieces scattered across space and time. For centuries, humanity has gazed at the stars. We've pieced it together slowly but surely, guided by the standard model of particle physics, our most successful framework to date. A rulebook that explains almost everything we observe, from the smallest particles to the largest structures. But now, a piece doesn't fit. A nagging inconsistency has emerged. Something's off, something isn't quite right. A tiny anomaly, a subtle deviation from the expected. That hints our rulebook is missing a chapter or perhaps even an entire volume. The standard model is powerful, incredibly precise in its predictions, but it can't explain dark matter, the invisible substance that makes up most of the universe's mass, dark energy, the mysterious force driving the accelerating expansion of the cosmos, or why some cosmic mysteries remain unsolved, defying our current understanding. These gaps aren't failures. They're invitations to discover more, to push the boundaries of what we know. Every crack in our theories is a chance to build something grander, more complete, and more beautiful. Right now, at the cutting edge of scientific inquiry, we're on the verge, poised on the precipice of a new discovery, of finding one of those cracks, a significant deviation that could change everything. A clue that could rewrite the textbooks, ushering in a new era of physics. Let's journey together, to the frontier of knowledge, to the very edge of what we understand, where a strange signal from inside an atom, a whisper from the quantum realm, could change everything, reshaping our understanding of the universe. This isn't just about particles. It's not just about the equations and the data. It's about human curiosity, the insatiable desire to know, and our relentless quest to understand the universe, to unravel its deepest secrets. The clue? What is this mysterious signal? A fleeting, possibly imaginary particle, a ghost in the machine that could unlock a hidden dimension of reality, revealing a universe far stranger than we ever imagined. If it's real, if this signal holds true under scrutiny, it might reveal a new force of nature, a fundamental interaction that shapes the cosmos. The puzzle just got a lot more interesting, a lot more complex, and a lot more exciting. Are you ready to follow the trail? Are you ready to delve into the unknown? Let's begin this journey of discovery. To grasp why a fifth force matters, meet the four fundamental forces that rule the universe. Gravity holds planets and galaxies together weak, but with infinite reach. Electromagnetism powers light, electricity, and chemistry, shaping everything we see and touch. The strong nuclear force binds atomic nuclei, overcoming the repulsion between protons. The weak nuclear force drives radioactive decay and fuels the sun. These four forces are the pillars of reality. Every interaction from stars burning to atoms forming follows their rules. But what if there's a fifth force hiding in plain sight? That's what scientists are now daring to ask. Deep within a Hungarian lab, a team of dedicated scientists were embarking on a journey into the unknown. These physicists, led by the insightful Attila Krasznahorkai, were about to stumble upon something truly extraordinary. Their focus was the enigmatic beryllium-8 atoms, probing their behavior with meticulous precision. They were diligently collecting data, fully expecting predictable results, conforming to established physics. But then, their highly sensitive detectors registered a strange, unexpected bump, a deviation from the norm. The data revealed that electron-positron pairs created in the decay of beryllium-8 preferred to fly apart at a very specific angle, precisely 140 degrees. This peculiar behavior simply wasn't in the rulebook, defying all known expectations. It wasn't a fleeting glitch, it was a persistent anomaly, stubbornly refusing to disappear. This perplexing signal was in direct defiance of the well-established standard model of particle physics. The meticulous team rigorously checked and rechecked everything, scrutinizing every aspect of their experiment, but despite their best efforts, the enigmatic signal stubbornly refused to vanish. What was the most exciting, albeit radical explanation for this strange phenomenon? Could it be that the beryllium-8 atom was, in fact, creating a brand new, previously unknown particle? A particle which then almost immediately decays into the observed electron-positron pair. Intriguingly, the observed angle perfectly matched the predicted mass of this hypothetical particle. It was as if a ghost particle had fleetingly left its fingerprint imprinted within the experimental data. The anomaly was undeniably real, confirmed through rigorous analysis and repeated experiments. And this perplexing discovery demanded the immediate and undivided attention of the entire physics community. Could this be the very first tantalizing sign of a completely new fundamental force of nature? The intense hunt for answers to unravel this mystery had officially begun. The vast universe had just whispered a tantalizing secret, beckoning us to listen closely. The Hungarian team called their mystery the X17 particle. X for unknown, 17 for its mass. Unlike any known particle, X17 didn't fit the standard model. If real, it could be the carrier of a fifth fundamental force, one that acts only at tiny distances and seems to ignore protons. The team repeated the experiment with helium and saw a similar anomaly. Finding the same ghost in a different atom made the evidence stronger. Scientists dubbed this possible new force protophobic. It shuns protons, favoring neutrons and electrons. If X17 exists, it's a messenger from a hidden part of reality. A new rule in the cosmic playbook could be waiting to be discovered. In the vast expanse of the cosmos, why does a tiny, almost shy particle matter so much? Because this elusive particle could potentially unlock some of the universe's biggest and most profound mysteries, revealing secrets hidden for billions of years. Dark matter, an invisible and enigmatic substance, makes up the vast majority of the cosmos, shaping galaxies and influencing the very structure of the universe. Yet despite its prevalence, we still don't know what it is, leaving a gaping hole in our understanding of the universe. X17, this hypothetical particle, could be our first real bridge to this hidden world, offering a glimpse into the nature of dark matter. Some bold theories even suggest the existence of a whole dark sector, a parallel realm of physics. This sector would have its own unique set of particles and fundamental forces, completely separate from what we currently know. X17, if it exists, might be the messenger particle, the key that unlocks the secrets of this dark sector. Furthermore, a fifth fundamental force mediated by X17 could also help unify the seemingly disparate realms of physics, bringing us closer to a complete understanding of the universe. Such a force could be the missing link, connecting gravity, the force that governs the large-scale structure of the cosmos, with the quantum world, the realm of the very small. Most importantly, the discovery of X17 would definitively prove that the standard model of particle physics, our current best description of the universe's fundamental building blocks, is incomplete. This would open the door to a new era of scientific discovery, pushing the boundaries of human knowledge. It would energize the scientific community, sparking a renewed sense of wonder and excitement about the universe. It would spark new experiments, pushing the limits of our technology and ingenuity. Ultimately, it would force us to fundamentally rethink our understanding of reality, challenging our most basic assumptions about the nature of the universe. The universe, in all its vastness and complexity, could be far richer, stranger, and more wonderful than we ever imagined. And it all hinges on one tiny particle, a ghost of a thing, that could change everything we thought we knew. That's precisely why the entire world is watching with bated breath, eager to witness the unfolding of this scientific revolution. Extraordinary claims need extraordinary evidence. So far, only one lab has seen the X17 signal. The scientific world is skeptical, as it should be. Other teams are racing to replicate the experiment using new methods and technologies. If they find the same signal, excitement will explode. If not, the mystery deepens. This is science in action, a global detective story unfolding in real time. Whether X17 is real or a mirage, the search itself pushes our knowledge forward. It sharpens our theories, inspires new technology, and reminds us that the universe still holds secrets. The adventure is just beginning. We're chasing cosmic ghosts, and the next discovery could be just around the corner. Stay curious, the universe is waiting.